Hi, everyone. Welcome to the September Wild Labs Variety Hour. I'm Talia Speaker, Executive Manager here at Wild Labs, and I will be your host today. So today we are super excited. We have four wonderful speakers lined up. First, Luke Ditria will start us off by sharing his experience designing and building high-power devices to operate continuously in remote locations, also powered by various AI and computer vision algorithms. Then Tim Fallon from Everett Communications will discuss how they work with EarthRanger to address communication and data challenges while working with conservation applications. Next, we'll have Ismael Brack, who will share potential errors and solutions for counting moving objects through drone mosaic images. And then we'll, per usual, take a little break for our Wild Labs quiz and some really exciting announcements today that we cannot wait to share. And finally, Jared Marley will wrap us up explaining how we can think about financing a healthier wildlife tech ecosystem. So with that, Luke, are you ready?
Yes.
Perfect. All right, I will hand it over to you.
All right. So, hello everyone. My name's Luke Ditria. I'm here in Melbourne, Australia, where it's currently just after 1 a.m. Um, I'm really excited to just briefly show what I've been up to and what I do. Um, so, as Tali introduced, I'm going to be talking about some of my experience building edge compute devices with a sort of ecology conservation twist. So my background is in electrical and computer systems engineering. I have a PhD in computer science in applications of deep learning here at Monash, at Monash University here in Melbourne, Australia. And that was also a part of the Australian Centre for Robotic Vision, where we use cameras to help robots find things, right, as a primary sensor. Um, my PhD wasn't really related at all to ecology. It was kind of conceptual or theoretical. But during that time, unrelated to my thesis, I was actually put in contact with some ecologists up in Queensland at Griffith University who were experimenting with a bunch of techniques that some of you are probably familiar with, using deep learning based object detection to process large amounts of footage that they collected from the field. So in this example here, they were using GoPros underwater to collect video of fish, and then they take that terabytes of data back and try to filter that out, detect this fish, count them, and potentially do species classification. There were other projects on environment utilization, beach utilization, doing detection and tracking that I was helping them with as well. Um, so while helping them through these projects, I was also thinking about other ways we could use technology. And I have a lot of interest in using low power edge compute devices to do the processing. So instead of collecting the data on device, taking it back to a server and then processing it there, we can record and process the data on device. So what I'm talking about is continuous real-time edge compute, where we're doing the processing on the device in real time, continuously. And that kind of started this whole series that I've been working on and posting on YouTube, where I'm been slowly over the last 12 months developing these devices and sharing it with the community. Maybe some of you have seen them. So about 12 months ago, I started putting together a device, the goal being to use object detection models running on a little NVIDIA Jetson Nano module to see if we could create a device that we left outdoors, just in the backyard, running continuously with object detections, shut down, start up, and collect data that way. So this first design was very rushed, put together in about a week, but it did sort of prove a concept that we could build these devices and had some learnings from that. From there, I looked at other technology that we could use, other devices that we could use to run our object detection models. I was aware of a whole range of what I'd call inference-only neural network accelerators, which we'd use to run our deep learning models. So Raspberry Pi actually released two modules or two accessories to the Raspberry Pi, the AI hat and the AI camera. The AI hat here uses the Halo 8 neural network accelerator. So I built a second device based on that, a little sleeker, a bit faster, fixing some of the bugs and issues of the older devices. So again, this is the Halo accelerator if you're interested. Again, I have more details in the YouTube videos if you want more on that. Uh, so I started to add some additional things. I've got an SSD here and connected the Raspberry Pi via 4G so that we're able to now deploy this in a remote location and actually send the detection data over 4G. So all the processing is done on the device, but we're just sending the actual results over 4G so we can log them in a cloud server. So I had this on a remote property and was just detecting kangaroos here. So again, all the processing is happening on the device. It's being logged and saved on the device, and the raw detection data is being sent over 4G. At the same time, I had a lot of interest from people wanting to build their own. Uh, this device here was a little pricey. The hardware itself is probably 600 US dollars altogether, not including the solar panel in the box. So I developed a smaller version based on the Raspberry Pi AI camera. It's small and compact, again, self-contained, powered by some lithium-ion batteries and the Raspberry Pi Zero. And again, that works pretty similar. All the processing is happening on the device. And I've recently also released a build video for that device. So if you're interested, the GitHub links there, all the code and the files are available for that as well. So in the last few months, I've been starting to take this a bit more seriously and taking all the information I've learned from the last 12 months that I've been developing this sort of part-time. And I've created the latest version, which is fully 3D modeled and 3D printed out of ASA, um, with high power solar charging and large capacity batteries. We've also developed our own PCB carrier board for the Raspberry Pi that has 4G LoRa, some switchable outputs, and the high capacity solar charging. I've also got another version here with an external battery pack with a big lithium iron phosphate battery and a camera with infrared lights. So this is for full 24-hour operation. And we're currently going to be trialing that here in Victoria on some projects. So hopefully some real world projects. Finally, there's been a lot of interest in the solar charging aspect of that board. So we're actually developing a Raspberry Pi hat that has high capacity solar charging for large lithium iron phosphate batteries. So if you're interested in that, you can stay tuned. And I'm pretty much on all socials. So I cross post all my content across all the socials. So you can pick your poison and reach out or stay tuned there. Thanks.
Amazing. Thank you so much, Luke. We had some enthusiasm in the chat. Super exciting. And it's great to see what an accessible way you're sharing this in. I was thinking of questions like, are you teaching people how to build their own? And then you answered a lot of those throughout. So that's great. I'm curious, what are some of the use cases that you're most excited about that you think this is really going to be game changing for?
Yeah, so the main reason I'm really interested in the edge compute aspect, processing data on the edge, is that we can now deploy it in really remote locations where network connectivity might not be the strongest, eventually even underwater. So back to the fish project, that takes a bit more doing though. So putting it in environments continuously for months or years, and just being able to collect the data with low bandwidth communications. And there are some other projects that we're uh, sort of collaborating with at the moment. I can't go into too much, where you want a quick response time. You want the detections instantly. You don't want to have to wait to transmit the data to the cloud and come back. Yeah,
Amazing. Well, thank you so much, Luke. If anyone has more questions for Luke, feel free to pop them in the chat and hopefully he can help address them there. Thanks.
thanks.
All right, our next talk is from Tim. Tim, are you ready?
I am. I am. Pleasure to meet everybody today. I'm excited to be here. So, yes, it's very nice to meet everybody today. We're with Everywhere Communications. Our company is headquartered out of Annapolis, Maryland, but I work remotely. I'm up in the Boston area. I saw already connected with somebody who's also from Boston. So it's really good to kind of experience the small world inside the conservation market. I'm really excited to meet you guys today. I'm on with one of my colleagues, our marketing manager, Katie Swihart. She's here with me as well. So quick way of introduction on myself. So really, if I think about my beginning at Everywhere Communications and how it relates to the conservation space, it starts one step before I joined the company. So my background before working at Everywhere, I was essentially full-time traveling. I had saved all my cash and gone on a backpacking trip after college. And on my trip through Southeast Asia and Africa, I fell in love with scuba diving. And scuba diving became something that I then wanted to do a marine reef conservation project with through a dive master program for anybody who's familiar. And I had signed up for one that was supposed to kick off in May of 2020, which obviously something happened there in that time frame that stopped the possibility of me going to do my conservation project. So I got stuck here in the United States. I was chasing down a job and got lucky enough to find Everywhere Communications, and really find a synergy between my conservation passion and sort of background in travel and seeing amazing things around the world, and safety and communications, which is what Everywhere Communications does primarily. So let me go ahead and jump into a little bit about the background on our technology. So Everywhere Communications provides three things that do three things. So we have a three-part solution with three major functions. And we have two partners that help us deliver the horsepower of our platform. So you might have come into today's call not knowing who Everywhere Communications was, not hearing about a small company from Annapolis, Maryland. But we are partnered with both Garmin and Iridium Satellite. So two powerhouse companies who help us kind of deliver our technology suite. So you see, we have a nice marketing tagline down at the bottom. The best of both worlds, Garmin hardware and Everywhere software. So if you are familiar with Garmin, they build the hardware product that we leverage on our platform. So Garmin has a hardware fleet called the InReach device. They're called Garmin InReaches. They give you satellite communications anywhere on Earth as long as you have a view of the sky. So the satellite communications network that these devices operate on is called Iridium Satellite, which is that logo you see over on the far right over there. So we always say we have a three-part solution. Part number one are those Garmin InReach devices. And you can see there's a number of different hardware types over on the left. There's puck-shaped devices. I have a couple here in the office with me. This is called the InReach Messenger Plus. So this device is a global satellite hotspot. It's going to give you global SOS tracking and two-way messaging from anywhere on Earth as long as you have a view of the sky. So that's part one of our solution. That's your satellite communicator. Part number two of the solution is a smartphone application. So we do have an app that you can Bluetooth pair with that satellite device. So that way you can know when you're receiving messages, where your teammates are. It has a map on that smartphone app so you can see where your teammates are in relation to yourself. And then lastly, we have a backend management portal. So there's an online web portal. Think of like an operations room or a dispatch center who's working at a national park in Africa. They're going to be monitoring a map where you can see the locations of rangers moving around, anti-poaching teams, vehicles, maybe visitors, maybe there are animals moving around on the map. So where Everywhere Communications plays a role with the conservation market is we can integrate our data into the EarthRanger portal as well. So we're a very interoperable system. That's going to be the next slide I show you, are some of the integrations that we have access to. But those are the three parts of our solution. We have an InReach device. Those are the satellite communicators. We have a smartphone application that you can Bluetooth pair with that device. Simplest win right there is you're just going to be able to use your keyboard on your phone. And then we have a backend management portal where you can set up configuration for devices and set up an integration to pipe your data into the EarthRanger portal. So the three major functions, we say we do three things. The three major functions of an InReach device, we'll start on the top right over there. Global SOS. So every single device has a panic button right on the side of that device. It's covered by a hard plastic flap. So you'd have to peel that SOS button back and then you'd push the button. At the Everywhere system, we are able to custom route that SOS event into any of your internal dispatch centers or anything like that. We can also route it to a 24/7 Garmin response center who's going to liaison a rescue based on your GPS location. In the middle, we have location monitoring and control. So these devices do tracking as well. So as you're moving around in the field, if you're a ranger or again, anti-poaching teams, really big use case for us. So if you're out in the field moving around, you're going to be recording track points over the satellite network. So these are going to give you a really powerful tool when you are operating in an austere environment out beyond cellular coverage. And then lastly, we call it secure messaging, but that's simply just two-way messaging to and from your devices. The devices can talk to one another. They can talk to cell phone numbers. They can talk to email addresses. They can also talk to the EarthRanger portal. So two-way messaging, location tracking, and global SOS. Those are the three core functions of the platform. And then if we get a little bit into our integration slide, there's a number of logos here on the screen. These are all portals or softwares that you may be using today that we are able to connect to and leverage essentially all the satellite information that I was just covering, tracking, location, being able to send messages, have geofence alerts go off, have check-ins go out to your devices. All of that information and that data that we're accumulating can integrate into any of the portals or the softwares that you see here on the screen. The big one for this market, the big two probably are going to be under the locate section, the second one in, with both the Esri portal as well as the EarthRanger portal. Those are both two different softwares that we can integrate into. And then on the right, the last column over on the right where you see ACT, that would be the response in the case that somebody on your team does push the SOS button because they've had an emergency out in the field beyond cellular coverage. By default, you see there's Garmin response, and then you see below that internal dispatch. So we can also custom route that into your team's kind of existing process flows. All right, and then this will be the last slide we cover here. Just want to cover our integration with EarthRanger. We say we're empowering conservation through innovation. So I've been working with the EarthRanger team for about 4 years now, and we recently launched a fully developed integration with them with the 4 key features that you see on the left side of the screen. So PLI, personnel location information, again, that stands for tracking. So we can integrate track points into the EarthRanger portal. Two-way satellite messaging. You can see this is actually a screenshot from EarthRanger. And that's a picture of me sending and receiving messages from the EarthRanger portal to my device and vice versa. So if you're at the Ops Center, you can just stay in EarthRanger. You can send and receive messages right through that portal. And then one of the last things that we're bringing into EarthRanger are our event-driven notifications. So primarily that's going to be SOS. If a device does have an SOS event, that alert can pipe into the events tab here in EarthRanger so that the Ops Center, the dispatch room, they're able to just manage one single pane of glass, one software through EarthRanger. And then lastly, scalable team setup. Think about being deployed in multiple countries, multiple different national parks, super dynamic operating regions, maybe even regions within national parks where you have 2 different teams deployed. We can have this set up at scale. Think Team 1, Team 2, Team 3, and then Team 1A if you're within a national park in the Western region, and Team 1B if you're in the Eastern region. And we can pipe all this data to the necessary endpoints as needed. So it's very, very flexible. That being said, Talia, I think that's it for me. I'm going to go ahead and kill the screen share. I'll make sure to drop my LinkedIn and my email address in here. I think that's going to be shared after, but really excited to connect with anybody who's intrigued.
Awesome. Thank you so much, Tim. Super interesting stuff. One question, I don't see any specific ones in the chat yet for you, but one question that I had is you said a few times in that presentation, as long as you have a view of the sky. And I know that's been one of the challenges for conservation applications is like, how do we deal with connectivity in rainforests or underwater or in some cases underground? And so I'm curious how you think about that. And is that still an issue we're navigating from end users and everything?
It's a great question. I'll answer the second 2 use cases first. So if you've never had any exposure to satellite technology, that is something to just kind of get used to and understand, whether it's the new satellite chips in your phone that are coming out, whether it's a satellite device like this that does text messaging, or if it's a fully blasted sat phone. It's just kind of the state of the market. You do need to be outside with a view of the sky for satellite technology to function. It's just kind of something to wrap your head around. Now, when it comes to being underwater or underground, there's not a lot that satellite technology can do for you in either of those 2 use cases. When you are underwater, because I do have a diving background, I don't know if anybody's seen the movie Open Water, but the inReach device is not going to transmit while you're underwater. So when you're submerged at 20 meters, it's not going to be able to transmit data, but you can get a dive case that pressure protects the device so that when you come up, if you've seen open water, and there's no boat there, you now have a communications device. So you can, talk back and forth. Maybe you got pulled in a current, maybe the boat left for XYZ reason, which should never happen, but you do come up with a lifeline if you get the dive case. So there is still some function if you're going to be in a diving scenario. And then when it comes to rainforests, these devices are extremely resilient with tree cover. They do function in rainforests. We're operating in all of the, the major rainforests around the world. They're called short burst data communicators. So they only need to catch a satellite for an instant to be able to fire your message. It's a teeny little data packet, and it only needs to catch that satellite for a microburst, and it can send your data. So inside of a tree canopy in a rainforest, you're still good.
Awesome.
And then the last piece I'll say is if you do go inside, if you have Wi-Fi or cellular and the satellite device doesn't work anymore, our app uses intelligent routing. So if you have cellular or Wi-Fi, the app is just going to start leveraging cell and Wi-Fi.
Perfect. Thank you
All
so
right.
much. Wonderful.
You're welcome. Thank you very much.
All right. Our next short talk is going to be from Ismael. So I'm ready to hand it over to you if you are ready. Perfect.
All right. Yep. Thanks.
Take it.
I'm going to present quickly things about counting animals in drone orthomosaics. I'm originally from Brazil. Yeah, now I am a postdoc in the University of Florida. So yeah, drones have been used widely to sample many different species in many different places. Their use are increasing fastly. And the most common survey method for terrestrial animals have been orthomosaics. Orthomosaics consist in rectified two-dimensional maps created from stitching overlap images. And yeah, they have like this problem that the methods to create orthomosaics assume that the landscapes are static. So when we are interested in counting moving animals, this can be very problematic. So imagine a flight like this, in which we are like flying these different lines with overlapped images with moving animals. Here we have the individual images, and then different types of error can arise when counting these animals. For example, we can count an individual more than once. The individual can disappear in the final mosaic, and we can also, depending on the method we use, we can have a ghosted animal, or the animal can appear cut in half. So we have discussed some strategies in this paper, how to deal with these errors. First, not using orthomosaics at all. I think that in many cases we can avoid using orthomosaics. We can just use the individual images to count animals. We can try to mitigate the errors in the orthomosaics by adjusting equipment or survey design by, like, for example, flying faster or using multiple drones at the same time. We can try to adapt the orthomosaic building methods, for example, trying to prioritize the pixels of the animals in the final mosaic, exemplified here. Or we can try to estimate these errors associated with orthomosaics. Importantly, these errors associated with orthomosaic building processes are they sum with other errors common in ecological samplings related to imperfect detection. So we tried to estimate these errors to correct the counts in this specific study during a mass nesting event of giant Amazon turtles in the Amazon. These turtles aggregate in sandbanks to nest, thousands and thousands of turtles in the rivers there. It's really an amazing phenomenon. And so we estimated these errors by painting the carapace of some turtles during 12 days of serving. And in a way that we could like identify these individuals in the final mosaic. So using these individuals, we were able to estimate some of these errors associated with the orthomosaic. For example, we saw that 12% of the turtles present in the mosaic were double counts, and 31% of the individuals that we observed in the single images disappeared when we tried to find them in the mosaic. So we built a statistical model to account for many different sources of error, including the errors associated with orthomosaic building. Some other errors that we had were related to the fact that turtles can return multiple times to the sandbank until nesting. So we have these 12 days of orthomosaics, and the same turtle could go back to the sandbank multiple times until nesting. When they nest, they just are gone. Then we could estimate, interestingly, like the differences in the population of these turtles in the sandbank, how the departures and entries of this turtle vary during these days. And we obtained this population size, total population size of around 41,000 turtles nesting in 12 days. This was really an impressive result for us. It has like a nice repercussion because apparently these characterize the largest aggregation of freshwater turtles in the world. So yeah, these turtles were usually surveyed using ground surveys. People went with a boat to these sandbanks and tried to count them from the ground, or they used a fence around the sandbank and tried to count all the hatchlings that emerged after the nests. So yeah, this apparently was a really nice development of serving methods for this species that we hopefully we expect this can be used to monitor different populations. That's it. Thanks.
Wonderful. Thanks so much, Ismael. That's super interesting. I'm curious, like, what are the next steps for this now that you've done all this work, like trying it on new species or in different settings, or what are your next steps from here?
Yeah, so in this paper, we kind of discuss different applications of this method for other species in other contexts, like in which orthomosaics can be used, like colonies of seals, for example, bird colonies also. We discuss different ways of trying to estimate these errors in these different contexts, and specifically for this species of turtle in the Amazon that can be that is actually threatened to extinction. We have this partnership with WCS, that is a NGO that works there. And they are planning like a large network for monitoring different populations throughout the distribution of this species using this method.
Okay, wonderful. There is a request in the chat for you to share your contact information again. So if you can drop that in the chat for folks to have that.
All right. Great.
Thank you so much.
Thanks.
All right, so now we are going to move to our little announcement section and then our quiz. So Henry, if you want to pull up the slides. Wonderful. Looks like they're just loading. Cool. Okay, so we have a couple of announcements from the WildLab side, and then we'll open it up for folks who set in registration that you might want to share an announcement or ask or some news from your side, and then we'll move into the quiz. So the first thing, do you want the next slide, Henry? First thing from the WildLabs community is that we have a new cohort of group leaders, as some of you may know, who are basically volunteers from the community who are helping to organize and facilitate our community interest groups for the next year. And they're right now looking for community input on what types of events, programs, and kind of like support that the community might need and be interested in. So if you're part of any of these interest communities or groups on WildLabs and you want to contribute your ideas, just go have a look at the discussion threads that are up there and let them know what you'd like to see. It could be things like events, trainings, different kinds of gatherings. So yeah, it'd be great to get your ideas. And then I think the next announcement will be from Adrian, actually. Adrian, do you want to jump in?
Right. So as you have understood, we are very, very proud to be announcing this save the date and sharing the information about the first International Conservation Technology Conference that WILD Labs, along with a coalition of key global organizations, are organizing next year in Lima, Peru, in February between the 18th and the 20th. So if you would like more information, please share your interest and we'll be happy to provide you with them. Thank you.
Thank you, Adrian. So exciting. You all are getting the first preview of anyone in the world of this. So we've just launched the article. Is the article formally out now? I assume so.
The article is formally out and I'm resizing the video, so it's on the social outside, but we wanted to make our community aware first via the Variety Hour because it's important for us to still have this soft launch beneficial.
Absolutely. So we'll share the announcement article link in the chat. This is really like early information, save the date. We're going to have all of the details and registration and call for speakers out, as Adrian said, in the coming weeks. But we are super excited. I know this has been something the community has been asking for a long time, and we're really excited to be working with a whole group of leading partners in the space to finally do it. So yeah, let us know if you would like to learn more. There will be exhibitor booths. So that's part of what we'll be sharing in the coming days for sure. But if you want to have, especially for those who are interested to engage in the organizing or to help support, definitely ping us and we can set up a call to talk about it. Wonderful. Okay, now we're going to move on to a couple of potential community announcements. I think Ginger is here from Hackster who might want to jump in with something.
Yeah, hi. Thank you for giving me the spotlight, Talia. And I'm Ginger from Hackster.io, and Wild Labs and Hackster are impact partners. Hackster itself is a 2.4 million engineering online community, and we have lots of technical experts, developers, engineers, makers from around the world host and post open source projects, on our site. More than 30,000 different tutorials from around the world that you can find on our site, and also a just great social network that's borderless, where you can connect with technical experts. We are hosting a competition right now called Edge AI Earth Guardians, and thank you, Talia and Adrian and Alex for featuring it, on the Wild Labs homepage right now. It's a collaboration also with other technology partners, and it's at a final countdown. So we're actually also here inviting anyone who has a conservation tech project. It's really easy to actually just post a story on Hackster and put it in as a submission for an entry. For further go-to-market opportunities, we're sending 5 finalists, to a Taipei event, and also other further on conservation tech, environmental activities we do in the future. So yeah, thank you so much for giving me the spotlight, and we're also bringing in some of our community contributors to share to bring them to the Wild Labs community as well, and hope there's more cross-community pollination and networking and knowledge sharing. So thanks again.
Wonderful. Thank you so much, Ginger. We put the link in the chat so people can go find out more there, and feel free to reach out to Ginger directly with any questions. All right, now I think everyone else who had announcements, I don't see you here today, so I think we're going to move on to the quiz. But feel free, if anything else comes up, feel free to drop other announcements and invitations into the chat throughout. So take it away, Henry.
Thank you, Talia. Okay, so many exciting things. And now for one more exciting thing is our regular quiz thing that happens during Variety Hour. So very excited to be taking over from Alex to deliver it today. Money doesn't grow on trees, but it can help to protect them. And the topic of this week's quiz is conservation, funding, and finance, because after all, conservation isn't just about protecting nature, it's also about getting the funding to make that possible. So yeah, hopefully we'll dive in and hopefully learn a few things today. There's some easy questions, some hard questions, but let's get into it. Starting with an easy one. So what type of funding is considered to be the most flexible in a conservation or like a charity setting? So is it restricted grants, A, restricted grants, B, project-specific crowdfunding, C, unrestricted grants, or D, in-kind donations? And please put your answers down in the chat. And I will open the chat.
We're getting a lot
of
C's. Yeah. Oh, you can see them.
Oh,
Henry.
yes, please.
Perfect.
No, but please help me out. That'd be great.
Okay. We got a B, a bunch of C's, a couple more B's, a couple D's.
Ooh, interesting.
Seems like largely C is the consensus.
Okay, we're getting largely C. Well, I'm pleased to announce that the answer is in fact C. Yes, it is in fact unrestricted grants. The key is in the name. I mean, a lot of those other funding sources are flexible, but the key is in the name for unrestricted grants because it's basically, there's no strings attached. It's up to the charity or whoever gets one to decide how to spend that funding because there's no restrictions around, what you're going to do with it. So it's considered to be the holy grail of charity funding. We love it when we get unrestricted donations because it means that we can spend it on all the boring stuff that happens behind the scenes. So yes, well done to people who got C. Okay, the next one is, which of these is a real-world mechanism used to fund conservation projects? So we've got A, selling carbon credits for forest restoration projects, B, biodiversity offsets for developers, C, naming newly discovered species for donors, or D, all of the above.
All right. We're getting some D's, B's, D, lots of D's.
Lots of D's.
See if anything. D,
any C's?
We are not getting any C's so far. We had one B and everyone else is D so far.
Okay. In which, if most people are putting D, I can confirm that yes, the answer is in fact D, all of the above. Carbon credits and biodiversity offsets are, of course, two ways of getting paid to protect nature, and they sort of fall more into that financing category. But of course, lots of donors are also attracted to the idea of having new species named after them. And I know that we've had donors in the past, or at least I've worked with donors in the past, that have a clause that they get first rights of naming any new species discovered in projects. So we're including that one as well. But yes, well done everyone who got D. Okay, so according to UNEP's 2022 State of Finance for Nature report, now it's getting difficult, how much investment is required to limit global warming to below 2 degrees C and to halt biodiversity loss? So is it A, $5 trillion, B, $9.5 trillion, C, $900 billion, just on the lower side there, or D, $20 trillion?
We're getting some D's, lots of D's.
Lots of D's, 20 trillion. Okay. These ones are usually the higher end, but are we getting any,
all right, B,
any more?
Got a B.
Got a B.
9.5 trillion. C, a couple of C's. 900 billion.
C's, 900 billion.
This is a tough one. Someone says
Sounds
pretty
like
tough too, but B.
Talia, what do you think?
I don't know, actually. I don't know the answer to this one.
Okay, I will provide the answer. The answer is, in fact, just a cool B, $9.5 trillion, which sounds like an insane amount of money, but considering that the net profits from non-renewable energy is around $4 trillion just in 1 year, I think it's possible. Let's just allocate some of that over to this instead. So yes, 9.5 trillion.
Good context.
Okay. Good context. Another hard one. Okay, in 2024, how much money was invested into clean energy globally versus conservation? I'm not going to read these ones out because there's too many numbers, so I'll let you guys just read.
We got crickets so far. Any brave first guesses? All right, A was our first guess.
Okay.
Couple of A's, couple C's, more A's, one D. A.
Okay. This is very hard, so I'm probably just going to show the answer. The answer is in fact D. So whoever put D, well done. Yes, it is there was $2 trillion invested in clean energy in 2024 globally, and around $102 billion invested in conservation globally, which is pretty good. That seems like quite a lot. Of course, the big difference is that there's a lot of clear financial returns for private companies to invest in renewable energy, much more so than in conservation. So it generally attracts a lot more investment, and of course, very important because of climate change. So yeah, it sort of shows that there is a bit more that can be done in the conservation world globally to become more attractive to investors and financiers. But yeah, we'll get there. And the final question, this statement, funding and financing are the same thing. Is this true or false? Okay, I'm seeing some answers pop up.
Everyone's saying false so far.
False, 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 false. Excellent. Okay. Well, I can confirm that yes, that is indeed false. And a lot of people do sort of assume that they are the same thing, but understanding the difference is quite important for us as a sector to sort of lean more away from the funding models and more into the financing models as we might need to do. So funding is obviously money that you receive to spend on conservation, and usually there's no repayment of that money. So that's grants, donations, or subsidies. And then finance is, of course, like leveraging money to make conservation happen, but often there has to be some sort of return at the end of that, with some sort of investment, like a loan. And yeah, there's a very clear distinction, and there's some text on the bottom giving some examples there, but I won't go through that to save on time. But yes, thank you. That was our funding and finance quiz, and I hope it was both fun and factual.
That was awesome. Thank you, Henry. I think we all learned a lot given the wide range of responses we got for a lot of those questions. I know I learned, so wonderful. And today's theme, all credit to Alex for suggesting that theme of the quiz, because it leads very nicely into our last talk from Jared, who's going to talk about financing a healthier wildlife tech ecosystem. So Jared, I'll hand it over to you.
Yeah, awesome. Thank you very much. And hopefully, Henry, maybe we'll have a few other answers to consider in the future here. Awesome. Okay, thanks. Well, thanks again. It's really nice to be here. Thanks to everyone attending, and WildLabs for putting this on. I'm really quite excited for today's topic. This is my day-to-day world, really, and that's not directly biology or ecology or the NGO side of things, but the day-to-day financing of wildlife technology. I'm kind of trying to have a bit of a tongue-in-cheek and fun approach to this. So I'm going to be drawing some analogies between biological and ecological terms and the business systems around wildlife technology. It's meant to be a little fun, hopefully trigger a little bit of debate and other thinking on the topic. With that, the ultimate goal here is, I think, the same for everyone, which is that wildlife technology needs to be better and cheaper. And I'm here to partially advocate why private enterprise, such as my own, is one of the solutions for that. And again, what kind of is necessary for a healthy ecosystem to survive in that. Bit about Margo Supplies. We're a 45-year-old technology company. We're based in Canada with US operations. Sold products all around the world, from rubber ammunition for polar bear deterrence to Svalbard, to radio network bird deterrence to the Nigerian Air Force. It's really been everywhere, but most of the base of the operations currently are Canada and the US. We're not totally alone in this field of companies. There's a whole tranche of businesses in 1980 to approximately 1995, kind of, that are still dominant in the field. You probably know a few of them, especially in tracking collars and audio listening devices. Why? Well, a few things. There was growing environmentalism. There's a disturbance event, and we're still seeing a lot of these same ones, which is availability of microelectronics, globalization, and trade. There's a lot of spending of government and NGO revenue at the time. And these kind of companies, similar to us, they're fairly small, often family operated. They really were too niche for big investments, and I'd argue largely in conservation technology that remains the case. But there's enough room for entrepreneurial individuals that could get by on, modest margins. And I guess for anyone curious, that's my dad on the left there. He built a net launcher, actually. used all sorts of different capture projects, collaring caribou initially. There was this duck stuck under a bridge in Calgary with a 6-pack ring on its neck. And anyway, he got it with his net gun. It was all on camera. He jumped off a bridge and broke his leg to do it. And that was in 1989. And then there's me on the right side. That's in a research camp in the Northwest Territories in Canada. And that's a bear and ground grizzly bear fence just around the camp. So that's a little bit about my background. And again, tying our kind of business to the wider legacy tranche of companies. Again, a lot of what I'm going to talk to about really applies to hardware technology companies like ours. And I guess like a good legacy company, my slides are pretty home built and my marketing the same. So going to kind of talking about different rules in our system. Let's look at it this way. So first of all, it's characterized by scarce resources in wildlife technology or conservation technology. I argue that should always be the case. In fact, globally, I'm not sure how optimistic I am, but really, if there's more funding, we should just do more. Easy enough. So we're always going to be limited by resources. We should always be more efficient. We should try and get this technology cheaper and better. In my analogy, calories are capital. It's about energy transfer through the system. A lot of businesses, we can compare them to grazers, and they're really doing their own calculation, figuring out exactly where they have the most efficiency. For example, a radio frequency engineer, they're going to have a much lower cost base and advantage in designing telemetry collars than a random company that would have to hire that talent out. We're always trying to optimize. So just like grazers in the Serengeti are employing optimal foraging theory, we have our own theory. A lot of that is going to rely on cost, price, scale, and risk. And the combination of those provides a margin often. The margin is what is that business going to produce? What's the net return of the business? Couple other major factors there. Something that's worth knowing is caloric deficit, we'll call it, which is in this industry, the expenses often occur much before the income generated from those expenses. You're employing people, buying inventory, selling the product, delivering it. Often it's on net 30-day terms or longer to get paid. And that's kind of one of the core problems and really one of the stumbling blocks you often find on commercializing, and that's cash flow. Finally, we always have to grow. There's no option as a private business. That's the role you're in. The reason is because we all die in the end. Entropy gets us. We need to continually generating more resources to hold in our own little networks so that one bad winter or extinction event or whatever doesn't wipe us out. Going to know your species. So we'll talk about myself. We're a hardware company. I'm picking pretty favorable metaphors for our own business, but I do think it's true. Hardware companies are really slow growing. We can call this like an acropora coral on a reef system. We're building structure, moving inventory. It's one thing to talk about ideas, but when it comes to hardware, you got to buy parts. You have to store parts. You need forklifts. You need machinery. You need a shipping desk. You need all these resources. And so we're constantly building that. Scalable growth is possible. Again, this is wildlife. Really, we shouldn't. There's very little opportunity or likelihood of like 100 times growth like you hear in kind of startup culture. But sustainable, scalable growth does happen in these kind of hardware companies. What's interesting, and this I think might be less commonly known, is how competitive hardware is. Similar to coral reef, you may not just look at it in a still picture, but it's a landscape of constant competition. And that's primarily because hardware is scalable. The best product gets the vast majority of the sales. Again, hardware companies, I would say we are resilient, but vulnerable to our own bleaching events. We currently got, inflation, at least in certain economies, volatile currency, declining environmental regulations in some countries. And so, we'll see how it goes. Just a comparison for the service side, could call them a schooling fish or a sardines. There's huge biomass in the service side companies. The vast majority of that global spending in conservation technology or conservation users is often in theirs. These are going to be typically environmental compliance companies. They're going to be surveying major projects, often infrastructure thing. It's a compliance-driven market. It's really simple cash flow, and they kind of boom and bust. They show up when there's big projects. They go into holding patterns when they're not. Okay, kind of going on with our analogies. Let's talk about opportunity costs. Low opportunity costs. Ideas are cheap. I mean that semi-jokingly, but it is true. What really, it might not be cheap in terms of energy and talent, but what costs ongoing capital or calories? It's wages, freight, rent, tax compliance, other regulatory compliance, brokerage fees, forklifts, boxes, postage, electricity, the list goes on and on and on and on. What I think is important, though, for customers to understand is to have an idea of the dynamics of the ecosystem so you can get the best value for your dollar. A lot of the people likely on this call, let's call you basal resources. These are going to be kind of small, generally available sales opportunities for companies like mine. Keep in mind, wildlife businesses, we're all cyclical. This is not a giant secret, but you can look at a company like mine or any other one, and you can get a pretty good idea of likely when we have strong sales and likely when they're slow. And I'll tell you, I'm a lot happier to make a deal in January than when we're going crazy in bird migration in North America. Same thing. When we're working on bigger projects, we can't get marketing material. That's something NGOs, academics, these kind of partnerships exist there. Let's talk about pulsed resources. Again, the basal resources, you guys aren't really the target for these kind of private enterprise businesses. We're looking at contracts, government and industry in particular. These are super high risk, high cost, high competition. They're often highly regulated. There's going to be huge compliance costs. There's going to be huge just sales closing costs. They're often impossible to generate marketing material from. So when you're working, for example, with us at an airport, I can't go on an airport and just start taking pictures and throwing that airport's name around on our own website. And these things are slow to pay too as well. So I kind of think of that's your annual migration of wildebeest. You also have to be strong enough. This is a cheetah, but if you're a lion pride, you got to be strong enough as a pride to be able to take down that big prey. So again, I guess referring to customers as prey, I don't know what that says about me, but basal resources, really, really important. Understand your unique value, and that's how you get good deals. Can kind of keep going through these metaphors. Private enterprise, it has gone both ways, and I think we've seen a lot of rot in the system. And when I mentioned before about these high ongoing operating costs, what tends to happen is in medium and late cycles is it eats into R&D spending. When you get these kind of systems with just not enough R&D input, you create all sorts of long-term weaknesses. You'll see a lot of biomass in uninvested capital. And there's a few companies in our industry certainly that do this. If you see a company of 15 people and 10 of them are VPs of something, I can tell you right there, they're making too much money. Again, you have a system that's filled with these actors. It doesn't adapt to changing conditions. It's vulnerable to tail risk. Resilient forest, okay, we're going to see continuous recruitment. There should be a large, wide, or a broad age class of companies, new ones, medium term, legacy businesses, balanced, healthy competition. Capital should be moving, just like in a forest. We want to see that energy not just sitting in one species, moving between them. It's biodiverse and stable. But I think the big thing is, just like a forest, this requires intervention and management, similar to what we might see in North America with indigenous burning. Same kind of idea here. I'm going to make the point that as non-private actors, there's a role in to help shaping the ecosystem that advantages you and that you want to see. So here we go. Why though? I've kind of explained what private enterprise is. What's the value of it? Does it really matter? Can we just totally replace it? I would argue no, of course.
Just to flag, Jared, you got maybe like 1 minute.
Oh, okay. Okay. Well, I'll do okay. Thank you. We tend to be stable. Again, we talked about that. Long-term solutions. When you call us that year for a project, we're ready to go, experienced, and there's value in that. The ongoing product support improvement, cost reductions, but what really I want to highlight is access to non-conservation dollars for conservation output. Our companies had the highest impact as a business in conservation in our area of operations, I would say, for grizzly bear, human-bear conflict. It's been sizable. For example, we fenced over 75 landfills in Alberta, BC, and the Yukon in many years past. The 75 landfills that used to have unrestricted access to garbage for bears. That didn't come from conservation. That money came from operating budgets of the landfills. We work with agriculture across provinces, and so there you go there. Now, for public and nonprofit actors, I'll be very quick. What you can do, you can encourage fierce, fair competition. Keep in mind fitness. Only 30% of small businesses in Canada survive 20 years. But as you can see on that graph afterwards, especially on the goods, that flattens out. And the biggest predictor of next year's survivability was your length of stay. Avoid single age class restoration. So we see a lot of grants in early stage startups, and that dries up the minute you show revenue. Still need to encourage that. So I encourage grants, I'd encourage opportunities, I'd encourage engaging, not just early stage businesses. For folks like you, mix suppliers up, try different products. And one thing that our industry is a little notorious for is demand transparent pricing. Everything we sell on a retail level has an open price on it. You can't have fair competition or effective competition if you don't know the cost. So that's a few things on broad smattering of it. Thank you very much for the time.
Thank you so much, Jared. I think these questions are coming up a lot and definitely are becoming more and more central to conversations about how we kind of create a sustainable innovation ecosystem, and something we think about from our funding grant side and everything. So super interesting to hear your perspective. We are already out of time, sadly, so we don't have time for questions now. But as always, we will stick around for after hours after we stop the recording. If anyone wants to hang around and pick Jared's brain or anyone else. So yeah, we'll just wrap up here. Thank you so much to our speakers, Luke, Tim, Ismael, and Jared. And thank you to all of you in the community for joining. And we will see you next time. Thanks so much.